Maayong adlaw. Good day everyone. Good day sir. I am Vince Venturado from BS Aeronautical Engineering. Well now, let us talk about our topic for chapter 3 of thermodynamics, which is the ideal gas. But before ko mag-start, allow me to ask a question, which is, unsa inyong impression when you hear the word ideal? Is it best? Is it complete? Or is it perfect? Because by definition, an ideal gas is ideal only in the sense that it conforms or it follows to the simple perfect gas law. So karon, let us tackle about the different gas laws. The first one is the Boyle's law. Just a little bit of history about this gas law is that the law was named after chemist and physicist Robert Boyle, who published the original law in 1662. Boyle showed that the volume of air trapped by a liquid in the closed short limb of a G-shaped tube decreased in exact proportion to the pressure produced by the liquid in the long part of the tube. So, sa iyang experiment, nakakonclude siya na if the temperature of a given quantity of gas is held constant, the volume of the gas varies inversely with the absolute pressure during a change of state. What does it mean is that if kung constant daw ang temperature sa gas, ang volume o pressure has inverse relation. Ang pasabot ani kay if mo increase daw ang volume, then pressure decreases, and vice versa. So, mauna ni ang ma-formulate niya na formula. Sa Boyle's law, the temperature is constant. So, we put T is equal to C. And also, the law states that the volume is proportional to 1 over pressure. So, we put V is proportional to 1 over P. Or we can say that volume is equal to a constant over pressure. Then, by multiplying both sides with pressure, we can come up to an equation which is the pressure times volume is equal to constant, or the PV is equal to C. Or if the properties of gas are changing, we use pressure 1 times volume 1 is equal to pressure 2 times volume 2, or the P1 V1 equals P2 V2. So, let us focus more on this one because at least for me, gamit kay siya. So, example problem ta. And the problem goes like this. In a constant temperature, to what pressure must a gas be compressed in order to get into a 3 cubic foot tank the entire weight of a gas that occupies 400 cubic feet at standard pressure? So first, let us put all the given data. P1 is equal to 1 atm. V1 is equal to 400 cubic feet. And V2 is equal to 3 cubic feet. Based on the problem, we can say that the temperature is constant. And P2 is missing. Now, we can use the Boyle's formula, which is the P1 V1 is equal to P2 V2. Since we need to find out the P2, we move the V2 to the other side of the equation. So the formula for this problem would be P2 is equal to P1V1 over V2. Now, let us substitute all the given data. P2 is equal to 1 ATM times 400 cubic feet over 3 cubic feet. Cancel both cubic feet and divide 400 by 3. The answer would be 133.3333 ATM. So that concludes our discussion about Boyle's law. Now, let us proceed to the next one, which is the Charles law. Well, just a heads up, if naglibog mo kung anong i-relate or coincide ang Charles law o Gay-Lussac's law, ang rason ani kay si Gay-Lussac did attribute his findings to Jacques Charles because he used much of Charles' unpublished data from 1787. Hence, the law became known as Charles' law. Well, this Charles' law is divided into two. The first one states that if the pressure on a particular quantity of gas is held constant, then with any change of state, the volume will vary directly as to the absolute temperature. Well, ang pasabot ani, if kung constant daw ang pressure, ang volume o ang absolute temperature will vary directly proportional to each other. But before tamo proceed sa formula, let us define unsa ang absolute temperature. Absolute temperature is defined as the temperature measured using the Kelvin scale. So, kung ang given sa problem kay in Celsius, we need to convert it into Kelvin. So, based sa state sa first part sa Charles law, mauna ni ang maproduce na formula. Since pressure is constant, we put P is equal to C. And the law states that volume is proportional to the absolute temperature. So we put V is proportional to the absolute temperature. So now we can use volume is equal to C times temperature, which is V is equal to CT. Then, by dividing both sides with temperature T, we have volume over temperature equals to C. Or if the properties of gas are changing, we use V1 over T1 is equal to V2 over T2. Or kung i-cross multiply nimo, we can use V1 times T2 is equal to V2 times T1. And the second part of Charles' law states that if the volume of a particular quantity of gas is held constant, then with any change of state, the pressure will vary directly as the absolute temperature. For the second part of the Charles' law, the formula would be like this. Since volume is constant, we have V is equal to C. And the law states that P is proportional to temperature, so we put P is proportional to temperature. Or we can say that pressure is equal to constant times temperature. Then, by dividing both sides with temperature, we have pressure over temperature is equal to C. Or if the properties of gas are changing, we use P1 or pressure 1 over temperature 1 is equal to pressure 2 over temperature 2. Or P1 over T1 is equal to P2 over T2. Or if we cross multiply, we have P1 T2 is equal to P2 T1. Now, let us answer some situational problems. Situation 1. In a constant pressure, a gas occupies 900 milliliter at a temperature of 27 degrees Celsius. What is the volume at 132 degrees Celsius? Karon, let us try to solve the problem. But before anything else, let us put all the given data. So V1 is equal to 900 ml. T1 is equal to 27 degrees Celsius. To make it an absolute temperature, we add 273 so that it will be equal to 300 Kelvin. And the third one is T2, which is equal to 132 degrees Celsius. Add 273 and it is equal to 405 Kelvin. Based on the problem, we can say that pressure is constant. And V2 is missing. So, what part of Charles' law ang atong gamiton? Tama, we can use the first part of Charles' formula, which is the V1 over T1 is equal to V2 over T2. And by using cross multiplication, we have V1 times T2 is equal to V2 times T1. And let us move T1 to the other side of the equation. So the equation for this problem is V2 is equal to V1 times T2 over T1. Now, let us substitute the given data. So V2 is equal to 900 ml times T2, which is 405 Kelvin, over T1, which is 300 Kelvin. Let us cancel both Kelvin and multiply 900 times 405 all over 300. And the answer would be 1,215 milliliters. That's it. Situation 2. Determine the pressure change when a constant volume of gas at 1 atm is heated from 20 degrees Celsius to 30 degrees Celsius. To start answering the situation 2, let us first put all the given data. P1 is equal to 1 atm. T1 is equal to 20 degrees Celsius. Add 273 to convert it into Kelvin. So we have T1 is equal to 293 Kelvin. And T2 is equal to 30 degrees Celsius. Add 273 and is equal to 303 Kelvin. Based on the problem, we can say that volume is constant. And P2 is missing. Basically, we can use the second part of Charles' formula, which is the P1 over T1 is equal to P2 over T2. By using cross multiplication, we have P1 T2 is equal to P2 T1. And by moving T1 to the other side of the equation, we have P2 is equal to P1 T2 over T1. Now, let us substitute the given data. P1 is equal to 1 atm times 303 Kelvin over 293 Kelvin. Let us cancel both Kelvin and divide 303 over 293. And the answer would be 1.03 atm. The pressure 2 is equal to 1.03 atm. So here na nag-end ang discussion about Boyle's law and Charles' law. And what if daw these two will combine or will be fused, so to speak? Is it possible? Pwede ba siya? Well, the answer is yes. Karon, let us talk about the equation of state or characteristic equation of a perfect gas. This equation gives the relation between absolute pressure, volume, mass, absolute temperature, and gas constant. To derive the characteristic equation of a perfect gas, we should consider the concept of both Boyle's and Charles' law. We can say that the system changes its properties from state 1 to state 2 by following both laws. To understand deeper, just follow me through this illustration. First, let us make a graph between pressure and volume. I-put nato ang absolute pressure sa y-axis and volume to the x-axis. So, for instance, we consider an ideal gas at the state 1. So, magbut natin direct state 1. The properties of the ideal gas in this state would be pressure 1 and volume 1. P1 and V1. Note that before the properties of the ideal gas change from state 1 to state 2, moagi pa siyang intermediate state. And this state will be denoted as A. So, magput ta dire og A. The system changes from state 1 to A by following the Boyle's law. And the path goes like this. And the path of the graph of the Boyle's law is PV is equal to C. Now, we have the properties of ideal gas in intermediate state. The properties are PA, and VA. So after that, from intermediate state, the properties of the system changes to its final state, or the state 2, by following the Charles' law. And the path goes like this. The path of the graph goes horizontally straight since Charles' law represents constant pressure. So this is our state 2. In the state 2, the properties of the system is volume 2, and as of the pressure is the same as PA. So P2 is equal to PA. And that's it. Let us use this illustration para mas masabtan nato giun sa pag-derive sa equation. Karon, mubalik ta sa derivation of the equation. Firstly, we should consider the Boyle's law. According to Boyle's law, the temperature is constant. So T is equal to C. It means that T1 is equal to TA. And this will be our equation number 1. And Boyle's law also states that PV is equal to C. That means P1 V1 is equal to PA VA. And this will be our second equation. And after that, from intermediate state to state 2, let us follow Charles' law. According to Charles' law, pressure P is constant. So we put P is equal to C. That means PA is equal to P2. And this will be our third equation. And also, V over T is equal to C. It means that VA over TA is equal to V2 over T2. And this would be our fourth equation. In equation 4, let us use the value of VA in equation number 2. So, from equation 4, VA over TA is equal to V2 over T2. Gamito nato ang value sa VA gamit ang equation 2 here. So, ang mahitabo kay from equation 4 and 2, we have VA dirigikan, which is P1 V1 over PA. And then napatay isa ka TA is equal to V2 over T2. Now, let us use equation 1 and equation 3. T1 is equal to TA. This is our equation number 1. And PA is equal to P2. So now, we can replace PA sa P2. And we can replace TA sa T1. So the equation will be from equation 1 and 3, makakam up taog P1 V1 over P2 T1 is equal to V2 over T2, or P1 V1 is equal to T1 equals P2 V2 over T2. So, mao na ni siya. So, from this equation, we can say that PV over T is equal to constant. That means constant can be replaced by R, the gas constant. Therefore, the equation becomes PV over T is equal to R. And if we consider the mass of the ideal gas, the equation PV over T equals to R becomes PV over T is equal to mR, or PV is equal to mRT. Or absolute pressure times volume is equal to mass times gas constant times absolute temperature. And this equation is called as the characteristic gas equation. And for our last sample problem, the volume of a gas-filled balloon is 30 liters at 312 Kelvin and 1.59 atm. What would be the volume at standard temperature and pressure, or STP? Let's start by putting all the given data. V1 is equal to 30 liters. T1 is equal to 312 Kelvin. P1 is equal to 1.59 atm. And T2 is the standard temperature, which is equal to 0 degrees Celsius. Let's add 273 to make it absolute. So T2 is equal to 273 Kelvin. And P2 is the standard pressure, which is equal to 1 atm. In this problem, V1, T1, P1, T2, and P2 are given. However, V2 is missing. So, any guess from you guys kung saan gamito na formula? Correct. We should use the combined gas law, which is the P1 V1 over T1 is equal to P2 V2 over T2. Or by using cross multiplication, we have P1 V1 T2 is equal to P2 T1 V2. And by dividing both sides with P2 times T1, we have V2 is equal to P1 V1 times T2 all over P2 times T1. Well, just a disclaimer, you can use any technique that you have. It's your own prerogative. So now, let's substitute the given data. So V2 is equal to 1.59 atm times V1, which is equal to 30 liters, times 273 Kelvin all over P2 T1. P2 is equal to 1 atm, and T1 is equal to 312 Kelvin. Let's cancel all the same units, which is Kelvin and atm. Now let's multiply 1.59 times 30 and 273, and that would be equal to 13,022.1, and divided by 312, and the answer would be 41.73 liters. So V2 is equal to 41.73. That's it. Well, I believe that's the end of our discussion for today's video. And I hope nakalearn mo basigamay from me. And that's it. Thank you guys. And always, may God be praised. Bye.